Hi, my name is Vishnu Vasudeva. Today, I'm excited to show you my app, DebateBot. DebateBot is an AI app that's meant to take debaters' speech and give them back a score and feedback on how to improve. It's meant to have three key features. First, it takes your speech and then transcribes it to text to then evaluate. It also takes direct text as an input. And finally, it gives back two mechanisms of feedback. First, it gives you a numerical score out of 12. Next, it also gives you detailed feedback on how you can improve. My app is meant for those who want help outside of school but can't access it. It's also meant for those who want someone to judge their speeches in their debates and give them an evaluation. And finally, it's meant for efficiency because it can give a score and feedback quickly. I built my app using four main platforms. First was VS Code to build the front end, back end, and also build the model to score text. I also used OpenAI's feature Whisper. This transcribes speech to text so that my model can evaluate it. Next, I use Fast API to connect my front end to my back end. And finally, I use React to design my UI and make my app look good. The model I'm using for my app is a support vector regression model to predict both essay and speech scores. SVM looks for patterns in the data that separate different score levels. Then these patterns predict new ones. It finds complex relationships that simpler models or other models might miss. I also tried other models that ended up not working out for me. The first was linear regression. It was too simple and it couldn't handle the variety in writing styles. I also tried random forest model. It originally worked, but it overfit the data, meaning it didn't perform well when it was given new essays that it wasn't trained with. The dataset that I used to build my model was a Hewlett Foundation automated essay scoring dataset. Each entry in this dataset included a student-written essay and then a domain score assigned by human graders. This score was used to build my model. The dataset was already split into training and testing portions. It was used to train and evaluate the SVM model for predicting writing quality. I used multiple features to predict the scores for my model. The first was a TF-IDF word patterns. This checks how important certain words are in predicting the score. Next was filler count and density. The amount of filler words decided how clear a passage was and how good its score was. Next, I used average word and sentence length. This checked for the content of a passage and made sure it wasn't too short or too long. Next, I checked for pronoun use. This checked back on writing tone and clarity. And finally, I used age of acquisition feature, which checks how old someone is when they acquire a word, or in other words, how complex the word is. And again, the feature that I used to transcribe speech to text was the Whispers feature from OpenAI. The evaluation metrics that I used to check whether my model was good was first the MAE metric. This checked for the average difference from real scores. My result was 2.09. In other words, predictions were usually within 2 points of human scores. The next metric was RMSE, which emphasizes large errors. The score I got back was 4.46. This means that there were few large mistakes in my model and that there was stable accuracy. Next metric I used was R squared. This explains how much variance there is. My score was 0.73. That means my model was able to capture most of the score difference across multiple essays. And the final and most important metric I used was a quadratic weighted kappa. This checked for the agreement with human graders. My score was 0.85, meaning that my model had an excellent match with human scoring. Now let's try out the app DebateBot. We'll be trying out 3 different passages to see how it evaluates them. The topic that we'll be using is whether or not phones should be used in school. First, we'll try out the method by inputting text. Great, now we have our passage ready. Let's check our final score. Here we get a nice side-by-side, where instead of having to scroll, we can see our score on the right and what we inputted on the left. We see that we got an overall score of 5, and we have a lot of feedback here. We have to try using less filler words, longer words, less pronouns, and more complex words. We also see that we get a filler count of 6, an average word length of 4.5, and a pronoun density of 0.12. Let's try fixing this now. This time, instead of using the text feature, let's try using audio. I think phones in school hurts students' concentration, disrupts their engagement, and hurts their ability to absorb info well. Here, now we can see that it's transcribed. Let's get the final score. Now we improved this time. We have a score out of 7. We still have feedback here, so let's try fixing it based on the feedback. Now let's go back to the text feature. Okay, now we have our perfected passage here. After taking in all the feedback, let's see the score we get. Great, we get a near perfect score out of 11 out of 12 after taking in all the feedback. And we see that we have a filler count of 0 and a pronoun density of 0. My app DebateBot is great for giving feedback and also scoring passages to help debaters improve outside of school when they need help. Thank you for listening.